Hey everyone. This is PostgreSQL threats and attacks in the wild. Quick intros. Hi, I am AJ Bahnken. I'm a security engineer at Mozilla.
I'm Forrest.
Oh, nope.
I'm Forrest Fleming, and I'm a senior security engineer at Procore Technologies. Today we're going to be talking about two honeypots that AJ and I wrote to emulate PostgreSQL. We deployed them to a few different servers around the nation, really. And this talk is really to present our findings from those deployments. Just a quick note: these were research deployments, not alert deployments, right? So we were using this to gather threat intelligence about attacks that are happening in the wild, as opposed to putting them in the network to see if there's a rogue actor that's trying to hit our threat or hit our honeypot, and then alerting on that.
Yeah, and so we want to do, before we get started, just a quick introduction to honeypots in case anybody in the audience isn't familiar. So generally, a honeypot is a purposely vulnerable system, made purposely vulnerable so that it can attract attackers, either for threat research or generally, as we were doing, or as Forrest was mentioning, something like in your internal network to notify you if there's attackers. That echo is super weird. And in the context that we're going to be talking about of purposely vulnerable networked service, there's main three types: low interaction, medium interaction, and high interaction. So low and medium are fairly similar in that they are a separate piece of software made to mimic something. So in this context, it will be a Postgres server, but it's not actually a Postgres server, just made to look like that. And we'll get into the differences between low and medium in a second. And the high interaction is typically like actually running a purposely vulnerable version of Postgres, sandbox in whatever way you want to do that. And we put these slides up on Sketched, and there's a link at the end of the slides. But if you're all interested in learning more about honeypots, I highly recommend the book Virtual Honeypots. And the HoneyNet project is an awesome project with tons and tons of awesome resources on their website. And then Awesome Honeypots just has a huge link dump of tons of cool open source honeypots and similar related software.
So the honeypot that I wrote is called Sticky Elephant, and it was inspired by Kippo and Cowrie. If you're not familiar with them, Cowrie is a fork of Kippo, and both are essentially Python packages or Python scripts that work to emulate a SSH daemon server and to give you a bash prompt when you log in. And they go a pretty far way to actually deceiving the person that logs in. They have a lot of really cool functionality that makes it look, at least for the first few minutes, that you're really on an actual bash terminal and not inside a Python program. Doing that emulation is what's known as being medium interaction. So it's not the high interaction where you have an actual thing. It's not quite the low interaction that we'll talk about in a minute, but it's doing some semblance. Sticky Elephant is not as advanced as the Kippo and Cowrie projects are. Mostly, it lets you log in, gives you your PSQL prompt, and pretty much anything that you throw at it, it's going to give you back the same query results. It's just hard-coded into the application. So this lets us sort of fool automated attackers, even though it wouldn't fool an actual human on the keyboard. So they don't get any errors from their scripts. Nothing's going wrong from an automated standpoint. So we get to see what sort of things are being run when they log in. I wrote this in Ruby. You can see the GitHub org be the root has our stuff. And I deployed this just a Cox cable internet home connection and in AWS.
And then pghoney, which is one I wrote, it's inspired by Elastic Honey. And Elastic Honey is a small little Elasticsearch honeypot that just has static, hard-coded responses to some of the common Elasticsearch API calls. And it's not quite that. Instead, it just mimics the Postgres authentication flow. And how it works is, as an operator, when you deploy pghoney, you define a list of usernames that, quote unquote, exist. And the Postgres authentication flow is that you tell Postgres, hey, I want to log in with this username to this database and some other stuff. And if that username exists, it'll say, okay, give me the password if there's a password required or whatever. And so this does the same thing, where when you say, I want to log in with this username, if the username's in the config file, then it will say, I'll ask for the password, else it'll just say, that username does not exist. And it's written in Go. You can find the code there. We'll have links to the GitHub org at the end as well, and deployed it in DigitalOcean and AWS.
Before we get started with the actual findings, I do want to throw some shout outs to the PostgreSQL documentation crew. Their docs are amazing. Both are actually implementing the auth flow that AJ and I both did in separate languages, as well as just having tons of information about the wire protocol that sort of, once you get over the pretty shallow initial learning curve of just navigating the docs, there is so much information, and it's so easy to begin to hack in support for a new type of query. I also want to shout out Jan Urbanski. I gave a pghoney talk called Postgres on the Wire. The slides were tremendously helpful for both AJ and I. And I wanted to note that when we initially wrote these honeypots, we were planning on deploying them as part of the MHN Modern HoneyNet project. As time went on, we decided that the actual operational overhead of running an MHN instance, the full bore thing, was really more than we wanted to do for something that was really supposed to be, you set up a collector, you wait several months, maybe check on it in the interim, but without needing a lot of operator interaction. So there is HPFeeds integration, which is what MHN uses for its logging. You can feel free to connect them to MHN on your own. We have some PRs into the MHN project that we'll be opening up fairly soon for that, but it's not what we actually used for our collections.
Sweet, so let's get into the exciting part, the findings. So first off, I wanted to start with some kind of high-level demographics about stuff that we saw. This is a number of unique IPs by country, and it's fairly, fairly typical. And US boxes are at the very top, right below is China. Makes sense. And then as well, the top 10 ASNs by unique IP. And so LeaseWeb Netherlands, and being at the top, they have boxes all throughout the European Union. So, right, Netherlands wasn't towards the top, but boxes throughout the EU. And then as well, we'll be talking about some of these specific hosting providers, but these were the location of actual attackers that we got. So the first attacks are on brute force attacks. So that's pretty much exclusively what I got. With pghoney, one of kind of the dream goal of it was to hopefully capture some interesting attack on the authentication flow for Postgres. I didn't get anything like that. Instead, the most interesting stuff I got was brute forcing. And almost all the brute forcing traffic was from China, France, or Turkey. And something interesting that I wanted to mention was that for all of the Chinese IPs that were doing brute forcing, I would see scanning traffic from the exact same class C about 1 to 2 days before something on the same class C subnet would actually do a brute force attempt. And as well, around, as you'd expect, around 95% of the passwords were either found in sec lists or were very obviously dictionary based, right? Like common transformations on the word password or administrator. And we will be opening a PR into sec lists for the around 200 passwords not found, and see if it's something that they find potentially useful or interesting. And as part of that 200 passwords that were not in sec lists are obviously dictionary based. Something that was interesting is running all of these passwords through a complexity score, 0 being the least complex, 4 being the most. The around 200 or so passwords, most of them were in the 3 or 4. Most of them were Chinese words and some were not. But I found that fairly interesting. And as well, something to just mention in regards to pghoney around the brute forcing stuff is to allow for this kind of, to make it much easier to analyze the actual passwords coming in. Postgres has a way to say, hey, give me the password from the client in clear text rather than an MD5 is the most common. And so it is a very easy a way to fingerprint pghoney at the moment, where if it's a server is asking for something in a password in clear text, that's not a very common thing.
So behavior on logon, if we just record the login flow and the auth, we get a lot of really cool information about brute force attacks, as AJ was talking about. What if we let them actually have a pSQL prompt and start running queries? What we get are a lot of robots. We actually saw 0 manual interaction in our pghoney instances, pghoney and Sticky Elephant deploys. A lot of bot traffic. We did see a malware upload that we'll talk about in a little bit. But before that, I want to talk about this sort of group of individuals that really, really, really wanted to mine Monero using our compute resources. And this is pretty cool because we got to watch the evolution of a particular attack group over the course of about 9 months. Now, as you can see here, they start out doing pretty basic bog standard stuff. It's just a call to syseval 999. That's a user-defined function dropped by SQL map. So superscript kitty, they're relying on a previously exploited box just hanging out on the internet, and they're trying to log in, use that function that was part of the exploit, and download a stage 2. They grab the stage 2. What that is just a shell archive that doesn't do much interesting. What it does is it kills a bunch of other Monero miners that could potentially be on the box, and then it installs its own Monero miner, and we're off to the races. Kind of interesting that they run the miner under temp SSHD, so they are trying to pretend to be an SSH daemon, but it's not a particularly well thought out or deeply deceitful obfuscation attempt there. We saw this attack started on March 3rd of last year and stayed doing basically the exact same thing with different IPs up until April 11th. Oh, I should go to the next slide, huh? There we go. Second verse, same as the first, a little bit different, not any much worse, actually. It's almost the exact same thing, right? It's syssun instead of syseval 999, but that's the same sort of thing. SQL map, user-defined function, exploit, drops it in their sort of default type thing, and they're still relying on the previously exploited machine. We saw this starting on April 15th. The attack servers, they start coming from wholesale internet, where they were almost exclusively coming from Linode before. The distribution servers are still pretty much exclusively on Linode. You'll notice a little bit of sophistication in the attacker is now grabbing different scripts, right? That's a different stage 2 up there. But it's really nice for us trying to sort of connect the dots of these attackers to make sure they really are the same person or the same group and not just somebody that bought the script on Xdetic or something. But luckily, when they switch the script name, the stage 2 name, they do it on the same distribution server, and then they'll switch distribution servers using the new script a little bit later, and they just do that, and we have a really nice clear path through the logs saying, hey, these are the same folks. When we do cut from syseval to syssun, we start grabbing impool.sh from the same distro servers. April 17th, we start grabbing pgpool.sh, and we do that for a while. Good.sh happens on May 3rd, but still the same sort of clear chain going around. We do a cut from good.sh to something a little more advanced, fr.sh, eu.sh, usa.sh, and you're like, oh, wow, they're doing geographic fingerprinting. This is the next step. No, they weren't actually doing any checking on anything. They were grabbing all 3 of those scripts and running them in sequence. Your guess, I think, is probably as good as mine. That started on May 7th, and around that time, they started doing a drop function on the syssun function. So I think that's probably to prevent themselves from reinfecting the same machine, wasting resources on owning the same machine over and over and over. Could also be evidence of other threats out there that might want to sort of take over the same territory. At the end of the month of May, they get a little bit, I don't know if more sophisticated is the right phrase, more brazen. They register postgre.tk and start using that instead of raw IPs for their distribution servers. I imagine they hadn't seen too much resistance. AJ and I shut down a few attack servers, a few distro servers, just emailing Linode and being like, hey, got some stuff going on here. And they came up within 24, 48 hours, again, from a different IP. So we stopped playing whack-a-mole there. They'll really stay on postgre.tk doing the same sort of thing until the next big move. And the next big move, is this. It's we start seeing concurrently with the syssun attacks some scanning traffic coming from Chinese telecoms. So the user logs in, they check the PG large object store, they check the version of the database, and they attempt to drop a particular object ID out of the large object store. And it's not a lot of different IDs at once. So we'd see one ID for a week or two, another ID for a week or two, and at the end we settled really on one ID that lasted for quite some time. And this continues all the way from basically May until August 4th, which is when the syssun attacks completely halt. About 3 weeks after that, we start seeing this guy, which is same sort of thing, right? It's a user-defined function that's being used to run shellcode. Shellcode in the sense of bash scripts, not in the other sense. It's doing the same sort of thing, but we never actually saw this function being created. And note the file name there. It's S and some digits. Those digits are the large object ID that was actually being dropped in the previous scanning traffic that we saw and had been seeing for some time. This would be pretty mysterious if it weren't for the folks at Imperva Security that did some really great research and were tracking these folks concurrent with us. That Monero address that you see there is the same one that this article, or this write-up that they published in March of this year, was finding. So they filled in a lot of the blind spots that we had when it comes to the actual exploitation of the machine, that is, putting the fun 810.170 function onto the machine and how they were distributing it. In this stage of the operation, it was actually a picture of Scarlett Johansson that was put on a public image host, and then the X binary was pulled out of that. You run the X binary, that drops the S binary. The S binary is actually the miner, and that gets run to do crypto stuff. I really encourage you all to read this, and our hats off to these folks for really being able to provide the final piece of the most advanced puzzle for this crew that we were tracking for almost a year. Really great work. So we have the syseval and the syssun crew, and they were pretty well connected. We know that they're the same crew pretty much, both using postgre.tk at the end. That's pretty obvious. And then there's the function call crew. A little bit of geographic shifting, right? Instead of line node servers out of the US, almost all of the attack traffic was coming from China. Can we really say that those are the two, or that those two attacks are coming from the same group? I think we can. First of all, is the fact that there was no exploit kit or distribution attack, or distribution contact for what I'm calling the function call folks, the fun 810.170 guys. So that's sort of interesting, right? Because it tells me that they were probably relying on some sort of previous exploitation. They were relying on that function being created at some point in a previous process that had occurred. And, well, what was that? Well, they knew that, quote unquote, that we were vulnerable from the syssun and the syseval phases. Also, look at the timestamps of the attacks. There's no overlap whatsoever between the syssun call and the fun 810.170 call. There's about 3 weeks where neither of those are happening. And if it were two separate groups, I would expect there to be some overlap. There would be some evidence that they're trying to take over the same machine. There's some kind of struggle going on there. We didn't see that whatsoever. And third is just the similarity of tools. So they're both using YAM, yet another miner, same arguments. They're using the same crypto mining pool at cryptopool.fr. Of course, none of that is conclusive, right? This is circumstantial evidence that they're the same, but we do think that the preponderance of evidence points to them being the same group. And since this is us trying to connect the dots of a fairly interesting, to my mind, attack group and not a court of law, I'm pretty comfortable saying these are the same folks. I mentioned malware storage. You might be thinking, oh, yes, they were putting something in PG large object. This was the single call we got to the PG large object store to land something, and it would make tons of sense if this were a Monero miner. It wasn't. It was a Windows rat. And it came from a Brazilian IP and was the only Brazilian traffic we got. So while it could conceptually be part of that campaign, it seems really unlikely to us. We're pretty sure it was just a one-off, and it was really exciting when the basic C4 came through and like, oh, let's open that up, see what it is. But it wasn't anything particularly groundbreaking.
Awesome. So we wanted to kind of, before we conclude, just have a quick slide on defense tips from doing this work. And I mean, the top part is really, it's in some senses funny, but I think it's still probably important to mention nonetheless, right? Like, don't expose your Postgres server to the internet, use good passwords, and don't run Postgres as root, right? And if you're installing Postgres from almost any package manager, it'll set up a Postgres user and do all that for you. From all the awesome stuff that Forrest was just talking about, restricting creation of user-defined functions is a good idea. If you can get away with completely removing that functionality from your Postgres users, that's awesome. Else, a common thing I've seen is the separation of like a Postgres user that your app actually uses, and then one that can do migrations that can create those user-defined functions. Also, it's important, I think, to remember that Postgres usernames are enumerable. And if you want to learn more about kind of the blue team side of Postgres, we link to this slide deck from Christoph Pettis at PG Experts, who did an awesome talk on securing Postgres, big, kind of in-depth look at Postgres as well as at the host for running your Postgres server. And so to conclude, what's next for this? I guess there's really just two pieces. The first one is, we started to talk a little bit about fingerprinting concerns. And there's some cool stuff that we could do and are interested in doing around further fingerprint mitigation. If you look at Kippo and Cowrie and some more, advanced or more worked on honeypots, they have tons and tons of stuff to deal with this issue, and as well information sharing. So we're not going to commit to releasing some big public disclosure of all the logs or anything, but if you're at all interested in talking to us about this, or getting some of the logs or any of that stuff, like please come and talk to us or email us or anything. I promise we're very nice. Yeah. And that's pretty much it. Thank you guys.
Thanks, y'all. We're honored to be here.
Yeah. I don't know if we have time for questions, I think. Huh? Can't see at all. Oh, what's up, Sam?
So you were with pghoney, you were requesting a plain text password. Did you see any connection drop-offs from clients that didn't want to give you a plain text password?
So to repeat the question, the question, make sure I understand, was did I see any drop-off from somebody who got the response and said, no, I don't want to give you a password in clear text? Yeah. I did not. What I saw mostly was either full brute forces, where there was hundreds and hundreds of attempts, or 5 to 8 attempts, which I think that, I don't know what to make of that, but they just tried a couple of passwords and a couple of usernames and then went on. So I hadn't seen that yet, but I imagine I will. And especially now that these are open source now, because they weren't originally, they'll probably be fingerprinted immediately. I can barely see.
That's it.
That's it. All right. Thank you all so much.